The next panel is all about the mid-band sharing in other countries and chaired by Michael Calabrese of the New America Foundation. Welcome, Michael. Great to see you.
Yeah, thank you, Steve. Well, of course, good morning or afternoon, perhaps even evening, depending on where you are. So, as Steve said, my name is Michael Calabrese. I direct the Wireless Future program at New America, which is based in Washington, D.C. We're a nonprofit policy institute that focuses on ubiquitous broadband for all. And of course, dynamic spectrum sharing is increasingly a leading means to that end. So welcome to the panel, Worldwide Initiatives to Deliver More Mid-Band Spectrum Through Sharing. As you've been hearing, dynamic spectrum access is a means to quickly enable more intensive use of underutilized spectrum bands while completely protecting incumbent services from harmful interference. In recent years, in order to meet the rapidly growing and increasingly diverse demand for access to spectrum, regulators have been adopting innovative sharing arrangements. These new approaches go beyond the traditional binary choice of designating a band as exclusively licensed or unlicensed. Most of this innovation has focused on the mid-band spectrum between roughly 2 and 7 gigahertz, which has become most valuable for emerging 5G mobile networks, as well as for private data networks, high-capacity fixed wireless deployments, and other innovations that we've barely touched the tip of. This panel brings together 2 leading regulators from the US and from Europe, as well as spectrum experts from 3 tech companies that have been at the center of expanding more efficient and intensive use of mid-band spectrum. So with that, I will briefly, let me briefly introduce the panel and then let each of them make a few introductory remarks. Then I have some questions, and then I hope that we'll have plenty of questions from the audience as well, since this is, we'd like to make this as interactive and inclusive a discussion as possible. So first up will be Alexander Kuhn, who is the Deputy Head of Section for International Affairs and Spectrum Policy at the Federal Network Agency of Germany. And he's been the head of the German delegation to the WRC and other international convenings, including being the chair of the conference prep group of the CEPT for WRC 19. And then Charles Cooper, a counterpart of sorts from the United States, who is the head of the Office of Spectrum Management at NTIA, which is the National Telecommunications and Information Administration. It's part of the U.S. Department of Commerce. He is responsible for frequency assignment and certification, since NTIA manages all federal use of spectrum. And previously, he was the Enforcement Bureau Field Director at the Federal Communications Commission. Third, Guillaume Lebrun is a spectrum consultant for Facebook based in Europe. And Dr. Lebrun has been he's been an active member of the spectrum community for 15 years, working for Orange, Qualcomm, Airbus, and now Facebook. We also have Andrew Clegg. Andy is the spectrum engineering lead for Google, and prior to that served as the spectrum manager for the U.S. National Science Foundation for 11 years, where he pushed the envelope on research in this area. And finally, Jennifer McCarthy, Vice President for Legal Advocacy at Federated Wireless, where she leads the company's regulatory and strategic advocacy on spectrum and wireless. And Federated, of course, is a has a spectrum access system, as does Google. So with that, I will turn it over to Alex to lead us off.
Thank you very much, Michael. Hello, everybody. I will not say good afternoon, good evening, or good morning. I just want to put together some slides for you in order to speak about some of the initiatives to deliver more mid-band spectrum through sharing and the sharing experiences we had recently in Germany. So first slide, please. Yeah, the main point of the sharing is always bring together very different expectations by the incumbents, by the newcomers. We heard about the verticals, we have the mobile operators, we have, of course, other operators as well, where we need to put everything together. What we would like to achieve are many things as well. We would like to facilitate, of course, innovation. That requires, in many cases, maybe cheap spectrum, that requires maybe exclusive spectrum. So you have different access possibilities which you need to address as well. What we would like to see from that point perspective, in all cases, we would like to foster competition. And in the end, we would like to have really see a growing interest of the small and medium enterprises and the industry itself in using spectrum in their production sites and also in their new communication. So what we've learned from COVID as well is that we have a lot of home office compatibilities, and these require also enough spectrum. So efficient use of spectrum, in particular in bands which are heavily used by mobile broadband, is an extensive part which requires then also a quality of service, a lot of coverage, and of course the right technology which allows sharing with others as well. So what we see as well from this part of the demand side is that many different users would like to have the spectrum only locally. They would like, on the other side, we have nationwide operators who would like to use it as well. And we learn from the discussions on 5G NR also that the EMC issues are coming back, and we need to provide information in that as well. One final thing I would like to highlight here as well, in order to come over to the regulatory challenges, is also what we don't want is that we have hoarding of spectrum. I think it's sometimes an asset which people would like to keep for certain purposes, but this should be avoided in any case, because hoarding is definitely the opposite of efficient use of spectrum, and therefore we would like to have really some movement forward. What could be seen as another possibility to access spectrum is also that you share capacity via new technologies, for example, network slicing or something like that, or we share the spectrum. So what have we done in Germany recently, in particular in the mid-band spectrum? Next slide, please. We've just awarded our spectrum for 3.4, 3.800 megahertz, and this has been done in a very to a certain degree to a traditional way. As I said, we have nationwide usage and also local usage, and we try to provide for every demand the right way forward. The right way for the nationwide usage is to a certain degree always an exclusive usage. So therefore there was an auction process for the mobile network operators, and they will provide public telecommunication services like mobile broadband. The big advantage of those mid-band spectrum here is definitely the big channel bandwidth, which provides then enough capacity for every single usages in that regard. So, but we took a different approach for the upper 100 megahertz, where we've seen a lot of demand by other local users, in particular those industry companies who would like to provide their own networks, maybe also on 5G technology, in a different way on a different local basis. And therefore we applied here a different process, which we can say we shared the spectrum on 3.4, 3.8. We said, firstly, we would not like to go through an auction process, because that takes away a lot of the possibilities and the funding for new networks. And therefore we looked for a different process here, and we used an application-based process. We also dedicated that one only to local usages. Of course, this can not only be done by the spectrum owner, it can also be done with the permission or with the commission provider. So they can also provide the spectrum to a mobile network operator, which is then operating their specific network on a local basis for them. And it's only for internal communications. That is something where we would like to achieve not any additional competition. We have also then that the obligation that the network operators should not provide harmful interference to the directly accessed mobile network operators. So therefore, there is an obligation to negotiate with the neighboring operators. That could be, as I said, either the mobile network operators or also some other local usages when you have side-by-side industry sides, which needs to move forward. And this is, of course, something where we would like to achieve, not something where we took spectrum away from the market for a very long time. Therefore, we will have a review process after 1 year, including a consultation of all the interested parties. And this may also include that we have possibilities for the mobile network operators to use the remaining part of the spectrum 3738 later on in the process if it is not in use. So some kind of use it or lose it principle is evaluated here as well. We've done that with certain assumptions. One of the assumptions here is that we have to use the full bandwidth of the 400 megahertz within the context and within our legal obligations also in Europe. And we need to move forward in that direction. We have seen also that we have a lot of use for satellite operators still in the band 3438, even if they moved up above 3.8 gigahertz. And therefore, we need to have some kind of trade-off here too in order to protect them. Most of them are situated in 3.4, 3.7, so the auction process and the usage conditions provide the essential protection here already, but we will not consider then any further establishment above 3.8 if we are not ensured that we do not have any harmful interference cases in that case. And a different example coming from the other end would be the next one. That's example number 2. So the next slide, please. That will be the 26 gigahertz band. Of course, it's not the mid-band spectrum, but it shows a little bit to another perspective what we can do on the other side as well in order to share the different users in there as well. So we used here also an application based process, and this is just the first come first serve principle. So we have to do only one thing to ensure the protection of the current use, and these are the fixed links and the ESS earth stations. Due to the situation in the band and the technical usage here, we do not think that it is necessary to relocate the fixed links, but we may need a future utilization concept in order to provide the necessary information. For us, it is clear that all the spectrum there could be used then for mobile operations on a technology and service neutral basis by everyone. And we will start, of course, the assignments with the upper first gigahertz because this is something which the European legislation requires to us. Also here we have the obligation to the negotiation of adjacent networks operators to get in contact and also work out if there are no harm and ensure that there is no harmful interference. And also we allow an individual coordination with other existing users. So if you have fixed links nearby, then you may have a coordination with the fixed links operator directly, and then you have also the possibility to use further spectrum on their local basis. Of course, here we use also the use it or lose it principle with the review of a period of 1 year. And we have some set up some kind of priority for those local users which may have in a very dense area of interest of spectrum not the possibility to reach anything. So if spectrum in a certain amount, I would say in a channel bandwidth of 800 megahertz is getting too close at a certain geographical point, then a local user may have some priority over the nationwide user because they can use other perspectives and other bands as well. So this has been set up too. What I would like to highlight here from both examples is that we try to use in all ways also electronic means. So all the application processes should be done by electronic applications and should be answered very quickly then in that case as well. So we're trying to adapt to a certain degree an automatic authorization process as well, and maybe we can use that in the future too. So that provides you with two examples on our way how we share the different demands around the mid-band spectrum, and of course I'm happy to discuss any further issue in the upper part of the 3.8 and also the 6 gigahertz band. Thank you very much for your attention, and I'm happy to answer.
Thank you, Alex. That provides quite a contrast in adjacent bands. So next up is Charles Cooper from NTIA. U.S. Department of Commerce.
Good morning, I'm Charles Cooper, the Associate Administrator and Director of the Office of Spectrum Management within the Commerce Department's National Telecommunications and Information Administration, or NTIA. Our office, known as OSM, is a spectrum manager for all the federal government wireless systems in the United States, ranging from the U.S. military to NASA to weather satellites to forest fire suppression. Our office assigns frequencies to carry out spectrum certification processes for all the federal agencies that employ spectrum for wireless communications, radar, remote sensing, and other uses. Next slide, please. Just to briefly review for our international audience, the U.S. has a distinctive approach to spectrum management. This is a historical legacy of how the spectrum was made available for widespread use in the earliest century. The Communications Act of 1934, which is our bedrock statutory authority, set up our spectrum management structure in the country. It retained the president's authority over U.S. federal government stations and operations, and that authority was eventually delegated to the NTIA. The act also delegated regulatory authority over other spectrum uses to the then newly established independent agency, the Federal Communications Commission. So here in the U.S., we have a bifurcated spectrum process, in which the FCC sets the rules for the non-federal users, such as broadcast and commercial wireless and other uses, and NTIA sets the rules for the federal government agencies. And our rules are mandated and covered by what we call the Red Book, which is shown on the slide. As you can imagine, this process requires administrative coordination and collaboration, which we achieve in several ways, including two standing interagency committee. One of them is called IRAC, the Interdepartment Radio Advisory Committee, which allows spectrum managers from all the federal agencies and the FCC to discuss potential decisions and actions on spectrum matters, including from a technical standpoint. And then, of course, we have the PPSG, the Policy and Plan Steering Group, which is a leadership level committee of policymakers from the executive branch agencies. And of course, that includes an an FCC representative as well. If we can go to the next slide, Jordan. So let's talk about the U.S. plan for mid-band 3 gigahertz. This cooperation has come into play continually over the years as our government has worked to identify and make available additional spectrum for the rapidly growing commercial needs. And of course, the mid-band spectrum is a prime example of this. As in other countries, the 3 gigahertz band has been spotlighted here as a harmonized band for broadband wireless networks, including 5G. Perhaps more so than other countries, however, this range has been constrained by existing government radar use and legacy C-band satellite operations. However, as a result of several separate decisions, the U.S. is making available the bands from 3450 to 3980 megahertz for wireless broadband uses. So a quick review, starting in the middle of the graphic, and what we've already been talking about is the CBRS service from 3550 to 3700, of which the lower 100 megahertz of that has been made available for licensed and licensed by rule use using a shared carrying framework that was discussed a little bit earlier. And of course, it's using dynamic spectrum access techniques. FCC has also acting to make the lower part of the C-band from 3700 to 3980 megahertz available with a 20 megahertz guard band on the top end, along with the consolidation of satellite operations from 4 to 4.2 gig. And then on the lower part of the screen, in August, the White House and the Department of Defense jointly announced plans to make the 3450 to 3550 megahertz band available through a combination of relocation and sharing of the federal incumbents. So we've got a pretty wide swath of contiguous spectrum. 530 megahertz is the goal from 3,450 all the way to 3,980 megahertz. We are continuing to look for other possibilities and other bands as well, keeping in mind the need for rapid and cost-effective repurposing approaches, as well as the ongoing spectrum requirements for the federal incumbents in those bands. Next slide, please, Jordan. Here, I'd like to mention what we're looking at for further development of dynamic spectrum access techniques on the federal side. Within NTIA, we're developing a spectrum sharing concept we are tentatively calling the incumbent informing capability. So rather than relying on the environmental sensing capability as was done in CBRS, the IIC would allow federal agencies to populate and update a real-time database with the frequency, location, and time of use information for the systems they deploy throughout the U.S. The secure database system would inform a SaaS system similar to the CBRS approach and would govern any commercial equipment in the shared system. This would open up a given band to shared use by the new entrant without harmful interference to the incumbent. Advantages of the IIC could include that federal users would gain greater control and security through providing their own accurate usage data to the database. And also the IIC would provide greater certainty for the commercial wireless carriers that would be able to share the wireless spectrum through dynamic automated access system. The IIC development right now is a joint effort between the NTIA's Office of Spectrum Management and the Defense Information Systems Office. Ultimately, we envision NTIA federalizing and administrating the IIC. So the IIC administration requirements will be included in the current effort in developing the NTIA's IT modernization architecture. We recognize that building a capability for dynamic spectrum access will be a long-term commitment, and there'll also be some trial and error. But we feel that the investment of the resources now will pay off in the future with increased spectrum access for both federal and non-federal users alike. Thank you.
All right, thank you, Charles. That is another tour of the 3 gigahertz band with a somewhat different combination of access mechanisms, which is really helpful. Third up, we have Guillaume Lebrun with Facebook. Guillaume.
Hi, yes, my name is Guillaume, and I'm in a global spectrum policy team at Facebook, and it's a real pleasure to be at this panel today to discuss mid-spectrum sharing. To me, what's interesting when discussing spectrum sharing is always to take a step back and try to understand what we're trying to achieve and what is the end game. And it really falls down into 2 categories. And it can be either local networks where you're trying to provide connectivity to a factory, or it could be a rural network where you're trying to deploy in an area that is hard to cover. And I'm going to try to discuss a little bit these two categories and what it means for spectrum regulators in terms of enabling spectrum sharing. When you start with rural networks, the way that mobile network operators are regulated is really based on the idea of infrastructure competition. And we know that infra competition is great. It brings price competition, it brings innovation, and the deployment are much faster. It is completely baked in the spectrum regulation. So the way that we do spectrum auction and this kind of things is really based on the idea that we have infrastructure competition as one of the goals of the spectrum regulation. Now the question is, of course, what happens in the geographical areas where there's not enough financial incentive to have several infrastructure deployed in parallel, and maybe only one infrastructure is economically viable. And that's where it makes sense to have a different kind of spectrum regulation and a different kind of spectrum sharing to enable like a single infrastructure to provide connectivity to these small villages, to these places where it's more difficult to deploy infrastructure. There are a few examples of that around the world. I'm sure that people have heard about Internet para Todos. So it's Telefonica in Chile providing this kind of single infrastructure, providing mobile connectivity to people in the rural areas. France had a program called Zone Blanche a few years ago, which was trying to do the same thing. And the UK Ofcom has really summarized this whole concept under the name of local access license. And it's a pretty good generic concept that regulators should really read about and understand. And why is it so important in the mid-band is that with 5G rolling out in the mid-band as the main spectrum where 5G is going to roll out, and the applications starting to use this kind of data rate that we're going to see, for example, in the C-band with 5G, it's going to be very important not to create another digital divide and to make sure that it's possible to deploy even in these areas that are very challenging for the operators to deploy in. And what does it mean in terms of regulation? The first thing is you need to be really able to pinpoint which areas are subject to infrastructure competition and which are not, which are too difficult to cover under infrastructure competition. The second thing is that it's a bit counterintuitive, but if you're reusing the spectrum of MNOs, sometimes you think, oh, it's not for MNOs. And actually, in the case of local rural networks, it's pretty much the MNOs that are your best partners to deploy this kind of single infrastructure in rural areas. So it's the same people. You really just need to sit around a table and discuss with them. And the third thing, which is probably the most important, is that it's not just about spectrum access. It's about all the economic rules, all the regulation that goes around deploying a network that need to fit right so that the incentives are there for the operators to bring connectivity even to these places that are really hard to cover. And so spectrum access can help. It really needs to be tailored so that the economic incentives are there. Moving on to local networks, and it's a little bit easier to understand. We're talking about a factory trying to have connectivity. We're talking about an airport trying to have their own infrastructure to provide connectivity. And the first question that typically comes is there a demand for this? And when you see what the Bundesnetzagentur has done in Germany, for example, as Alex was saying a few minutes ago, these licenses in 3.7, 3.8 have been subject to quite substantial demand from pretty large company, smaller company. You're talking car makers. One particular example that impressed me is Lufthansa Technik. So basically, they acquired a local license, and instead of having engineers flying from all around the world to basically repair engines, so big airplane engines, what they do now is they can do it through video streaming, through very high quality video, because they have their own local 5G network running. So that there's a demand for it, and the question is, what are the considerations that a regulator should ask himself to put this license in place? So the first thing is that typically these big factories or these big repair center, they're not that far away from cities, so typically it needs to be a band which is only open to local networks. But at the same time, these people need an ecosystem, so they need to be part of a whole ecosystem to be able to get their hand on equipment. If you look at the two different initiatives in Europe that are the most famous, so Germany is in 3738, the way that they solve it is by taking 100 megahertz from the band which was seen to be for the MNOs, and they dedicate it to local networks. Now this got the benefit that the local networks have got the terminals. Of course, the problem with that is that the mobile network operators have got 100 megahertz less. The UK took another approach where they opened the 3.8 to 4.2 to this kind of local networks. And there is a question, where is the ecosystem? Like, is it very easy to get access to devices when you don't have MNOs driving the volumes and driving the scale? But once again, I think it's just about the generic concept of shared access licenses, as the Ofcom put it, and understanding that, once again, it's the economic and incentives that are behind this model that needs to be taken into account to ensure the success. So whether it's rural networks or local networks, it's not just about tweaking the spectrum regulation. It is important to do it. It's important to share the spectrum, but it's also important to align the incentive and make sure that the ecosystem is there so that the actors locally can basically provide connectivity where it's needed and achieve the goal that they had in mind. Yeah, and that's what I wanted to talk about today. Thank you.
Thank you, Guillaume. We have Andy Clegg next from Google.
Great. Thanks, Michael. I'll just say a few introductory words, and then it's more fun to get to the discussion and the questions. But thanks for having me on this panel. So, I'll say a few words about what we're doing here in the United States with regard to mid-band spectrum. We've got a lot of spectrum sharing concepts that have been deployed or are on the table for future, and it's interesting to take stock of how we're doing so far, and what kind of lessons we've learned, things like that. So of course, as Dave Wright mentioned in the previous session, and Charles mentioned earlier, we have deployed CBRS in the 3.5 gigahertz spectrum. We began initial commercial deployment about a year, almost exactly a year ago. Full commercial deployment began in January of this year. And despite the pandemic, we're approaching 100,000 deployed base stations so far. So that's a lot, especially given that one of the major use cases for CBRS was enterprise, so for offices and other areas that aren't being populated right now because of the pandemic. So we expect that once once we're able to get back to the offices and things like that, we'll see the CBRS expand even more quickly. We have, in the United States, the mid-band spectrum, and I'm talking here in particular about 3 gigahertz, basically from 3 to 4 gigahertz. Compared to other countries in the world, our mid-band, our 3 to 4 gigahertz part of mid-band is a lot more complex than other parts of the world. For example, the 3.1, or actually the 2.9 to 3.65 gigahertz portion is heavily used by our Department of Defense for various radar systems on ships and airplanes and on the ground and things like that. And so we have to obviously share spectrum with them if we're going to use mid-band spectrum. And CBRS is about sharing, and the Department of Defense is one of the main incumbents in that band. And we've worked out a way to share with them. We have to sense and avoid their radar operations in the band. And so far, that's working well. Even though we're approaching 100,000 CBSDs or base stations deployed, we've had 0 claims of interference from the Department of Defense. So that's very good. And in fact, I would argue that we're overprotecting them, because if you never interfere, that means you're not pushing the envelope. But it's good to know that we've had no claims, not just no substantiated claims of interference, but so far no claims of interference from incumbent operators. So that's good. Charles mentioned that the FCC and NTIA and DoD are working together, looking at the 100 megahertz just below the CBRS band, 3450 to 3550. The FCC has sort of fashioned that so far in their proposal as something different from CBRS, a little higher power, more sort of macro cellular. But it'll still be a sharing situation, because the DoD still operates radar systems in that band. And there are going to be areas of the country where we have to share either on a static or dynamic basis. And so we'll still be applying some of the concepts we've learned from CBRS to that band. And now, of course, below 3450, the DoD, NTIA, and others, and FCC are looking at perhaps gaining some access for broadband systems even down to 3100 megahertz. But that's a farther future thing. And that is, again, heavily occupied by Department of Defense radar. So it's a bit of a challenge. Just above the CBRS band, as many of you know, the FCC has cleared part of what was traditionally the C-band downlink spectrum it extends from 3700 to 4200, but the FCC is looking at clearing 3700 to 4000, and then using some of that 3700 to 3980 cleared and auctioned for 5G systems. Now, the Department of Defense does not operate in that band. That's a non-federal band, so there's no need to share with the Department of Defense there. So that'll be cleared, and I think that'll go for quite a bit at auction, because it'll be very, very nice prime spectrum for higher power macro type systems. So that's very exciting. And then finally, looking farther up the scale at 6 gigahertz, we've adopted a framework where unlicensed devices can be deployed in the 6 gigahertz band. Either if they're low power and indoors, they can do it autonomously, but if they're higher powered access points, unlicensed access points, they need to check with what's called an automatic frequency coordinator, AFC, and they can start operating. And then the AFC can make sure these devices won't interfere with incumbents. There's about 100,000 fixed point-to-point incumbents in the band that need to be protected. Some of those support critical services. So we take that very seriously. But again, it's sort of one of the, another application of the cloud-based spectrum sharing model like we have at CBRS. So it'll be very exciting as that starts to come online. I don't have a whole lot of time for lessons learned from CBRS, but I would like to put one thing out there, and Charles mentioned it earlier. They're looking at this incumbent informing capability, IIC, which I think is critical. In my opinion, the environmental sensing capability, and that is the sensors that detect the military radar and then reconfigure the operations in the band to avoid interference to those radars, I believe has some serious problems with it. One of the major problems is that you have to protect those sensors themselves from in-band interference so they can hear the radars, and that causes massive disruption to CBRS in the surrounding area. Too much disruption to CBRS in the surrounding area. So basically, it's almost like quantum mechanics. You're basically tweaking the very system that you're trying to protect. So I think having the IIC is very important. I would encourage NTIA, DoD, and FCC to consider, if they develop IIC for 3450 to 3550, to actually extend that framework into the CBRS band so that we can move away from ESC and have a much better system that doesn't block so many CBRS users. So I'm going to stop there. I don't want to take too much time, and I'd like to get over to the questions and the discussion after Jennifer. So thank you, Michael.
Okay, thank you, Andy. That was a great setup. And our final panelist, last but not least, Jennifer McCarthy from Federated Wireless.
Thank you, Michael, and thank you, Martha and the DSA for having me today on this panel. I'm Jennifer McCarthy, Vice President Legal Advocacy for Federated Wireless. You may know us as one of the Spectrum Access System Administrators for the CBRS band and a prospective automated frequency coordinator for the 6 gigahertz band. Andy did a great job reviewing mid-band spectrum activities here in the United States and the ways in which a lot of the same technology and capability that we've developed for the CBRS band is being considered for application in adjacent bands and up again at 6 gigahertz and possibly elsewhere. 12 gigahertz is a possibility. 7 gigahertz is one that's pretty similar to 6 gigahertz. So there are other bands where the same dynamic sharing technology we think holds a lot of promise and can make more efficient use of the spectrum, allowing both incumbents to continue to operate and grow their systems, while also allowing new entrants to come in and start making more efficient use of these bands. Picking up on a few of the discussion points that have come up already here today, just thinking about ways in which this automated dynamic spectrum sharing technology can really live up to its full potential and enable some of the early sharing and different licensing approaches that are being considered to meet their full potential. And some lessons learned, frankly, from what we've been doing in CBRS and the success we've had to date. Andy mentioned that we're rapidly approaching 100,000 base stations that have been deployed in the past year alone in the CBRS band. That's a lot of deployment. And I think people need to realize that's happening on the shared spectrum, the third tier, the general authorized access tier. That's before the auction was really even completed and the PAL licenses have not yet even been issued by the FCC. So if you think about the ecosystem, which Dave mentioned in the previous discussion around the CBRS band and how we've achieved that, I think one of those important lessons is to realize that these local licensing approaches or shared licensing approaches need to be contextualized with the more traditional licensed access. And I think Guillaume brought it up in his talk a few minutes ago. Making sure that the ecosystem works for both lightly licensed or shared access, in addition to the traditional license, is really the best way of ensuring that your ecosystem grows and that the traditional MNOs and larger players have a way of accessing the spectrum that they need, and that the enterprises, verticals, and others also can take advantage of that same ecosystem. So we would strongly recommend that both licensed and unlicensed access options be considered as part of the same technical rules and even many of the same service rules, and allow different access options within the same band subject to equipment interoperability requirements, which in turn will continue to drive ecosystem development. Another point that was raised earlier by Alex about what they're doing in Germany is the idea of the local licenses and the use it or lose it approach that they've taken to their 3.6 to 3.8 or 3.7 spectrum, I should say. We love the idea of making sure that people are putting spectrum to use. we might suggest that instead of use or lose it, that you consider setting up a bright line test and implementing something closer to the CBRS use it or share it approach, where if a licensee has acquired some spectrum for a large area, but they're only using it in the most densely populated area, for example, with a bright line test, making sure that their use is protected, the rest of the spectrum, if it's not being used, could be shared and used by those enterprises, those verticals, other folks who might need access to spectrum and are willing to come in and use the leftover, if you will. And if you combine that with an incentive to engage in secondary market leasing, for example, that might be another way of streamlining that process and ensuring that enterprises, verticals, other local users may have the ability to get access to unused spectrum that the MNOs don't intend to use themselves. Finally, I'd also recommend that the automated capability that we've implemented in the CBRS band is something that's really exciting and I think really applicable to a lot of these other sharing schemes. Again, if you create bright line tests of how to protect incumbents or how to protect an MNO or a large nationwide licensee, the automation that we've put in place can very quickly determine where spectrum is available and allow folks who are looking for spectrum access options to assess their opportunity and determine whether or not they are interested in investing in a deployment in a particular area. But having to wait months, applying for a potential license, waiting months for that determination starts to discourage that type of investment. And we think having an automated capability where these types of decisions can be done far closer to real time is really beneficial to the ecosystem in general. And then finally, the last part of this automated capability, an added benefit that we have is the synchronization of TDD systems. We know that this is an ongoing issue for operators and regulators around the world, whether the regulator should mandate the particular frame structure for TDD systems to avoid even intra-band interference amongst the TDD users. In the CBRS band, one of the things that we've managed to do is use the Spectrum Access System, the SAS, dynamic sharing capability to set up an industry-led way of synchronizing amongst TDD users. And this will help both within the band and across band edges. Again, thinking about CBRS and future C-band licensees, we think there's a really good opportunity there to leverage the SAS to minimize interference amongst those TDD users. And again, in the upcoming 3.45 to 3.55 band, we think again that the SAS coordination will go a long way to enabling coexistence amongst those TDD users. So all these ancillary benefits that come from a system that was initially designed to share with the military, but has lots of benefits for industry and regulators alike in addressing spectrum access challenges. So thank you. I look forward to the questions.
Thank you, Jennifer. That's terrific. Well, we now have a whole lot of great information on the table here for our discussion, and the audience has already suggested asked a few questions. So please, if you do have questions, put them in the chat, and we will try to work them in as we go. So we should have enough time if we are fairly crisp. So let me start by asking, I think Jennifer perhaps first, but anyone really, much of the regulatory innovation we've seen in relation to mid-band spectrum has been in response to demand from smaller players that want to deploy in more localized areas or inside their own factory or other venue. And Alex, of course, mentioned this in relation to Germany's application-based mechanism. This demand is expected to increase as enterprises deploy and customize private IoT networks. How can regulators ensure that local ISPs, enterprises, schools, smaller players can all get access to spectrum directly and at the same time benefit from a solid device ecosystem?
Yeah, thanks, Michael. I think that was exactly the point that we were just discussing, was the idea of having both the certainty of access and the ability to get an answer quickly about what spectrum is available to you in a particular geographic area. And then again, also having access to that larger ecosystem, which, as Guillaume pointed out, is, the MNOs are the ones driving, the development of that, at least initially. So, we really like the way the CBRS band has been set up from that perspective, with having both licensed options as well as lightly licensed options within the same band with an interoperability requirement. And then that, again, use it or share it capability that can give additional access for local users, whether they are WISPs that are providing commercial services, or enterprises or schools that are providing service only to themselves. But having that flexibility, I think, is really what's important. And again, having the automated capability that can implement this quickly and enable folks to understand, what spectrum options there are for them given their particular use case and their geography. And it makes more efficient use of the spectrum, frankly, rather than having a first come, first served approach. Using the automated capability we've developed for CBRS might allow the same spectrum to be reused in a particular area for somebody who's using it internally within a building or a factory, and then also allowing somebody else to deploy a wide area network outdoors. Having the dynamic sharing capability, performing that computation and analysis, I think makes a far more efficient use of spectrum ultimately.
Great. Is there any other European perspective on that, or anyone else?
Well, I could not agree more with what Jennifer just said. One additional element to that is, of course, economies of scale. And that's something that in the US it's just granted because of the size of the market. That's something we need to keep in mind. The reason why the MNOs can drive this ecosystem is because they're deploying lots of terminals, lots of base stations. If you have a big enough market, you're going to do the same thing. Even if you have different local players coordinating, they're going to drive an ecosystem too. So it's just about the size, making sure that the solution is reasonably harmonized. Of course, if you got the size of the US, it's perfect, but it's even better if you had Canada and Mexico, right? And it's the same thing for every country. Just making sure that you try to drive as large a geographical area as possible.
Okay, great. Let me ask, I'm sorry, someone else have a point on this?
There was one thing Guillaume mentioned and also Jennifer mentioned here, and that's a competition issue. If you go forward with nationwide coverage and the big enterprises are moving forward for the mobile network operators, and you have the WISP getting the spectrum for free, so you may create some competition. That can only be assured or aligned in areas where you do not have coverage right now. So you need to have these blank spots where you have then the incentive of using a system like CBRS in order to provide the service. Otherwise, you create a competition between someone who paid for the spectrum and someone who hasn't paid for it. So, and we need to take this into account as well. And that was one of the perspectives where we said in Germany, well, we have to go into more coverage obligation areas instead of just picking some white dots in Germany where we have an automatic system. There are less of them now that do not create some kind of the allowance of moving forward with some CBRS-like systems. But the other recommendations from Jennifer regarding her 5G synchronization have been taken into account, and that was exactly the incentive from our technical regulation on 3738, that every operator is moving forward in the same way. And we'd like to also really set an incentive due to the technical regulation in place that they are moving a minimization of the interference to the other networks. So synchronization is key of one part, and at least the network negotiations with the other neighboring networks as well in order to minimize any cases of interference, and that may require also further work in that direction. But for that one, we are also therefore to provide further advice. Thank you.
Andy or Jennifer, do you have any explanation about the GAA, the rationale for GAA? And I just wanted, because Alex was mentioning that it seemed possibly unfair that that WISPs or others could receive free access to spectrum similar to what was being licensed in the band. What are the trade-offs there?
So it's not actually equivalent to the spectrum that was auctioned. The spectrum that was auctioned, when you buy it, you get some level of interference protection rights. You are protected from interference from other priority access licenses, and you're also protected from interference from the GAA tier. If you use GAA, it's not unlicensed. It's technically lightly licensed, but it's very much like unlicensed. You're on your own there. You basically have to accept any interference that you receive, and you really should, and you can't cause interference to priority access licenses, and of course not to incumbents either. So you're not guaranteed a particular quality of service. You're not guaranteed access. You're not guaranteed interference protection. So it's actually, from that perspective, it's very different from the priority access license, where you do have an expectation of interference protection. But the other important thing about the GAA tier is it keeps the priority access license tier from warehousing spectrum, because if you don't use if a PAL, a licensee, doesn't use their spectrum in a particular corner of their license area, GAA can come in and use it. And so you can't buy a license area and preclude anybody else from using that area just by virtue of the fact that you own that license. You actually have to deploy. The spectrum access system knows where you've deployed, knows what your coverage area is, and outside the coverage area, the GAA is allowed to access it. So it keeps you from warehousing warehousing spectrum. So, those combinations of factors make GAA very different from any other type of service, I believe, but also, clearly establishes what you're getting when you pay for a priority access license.
Right, and that last point is the use it or share it concept that Jennifer referred to, which I'll come back to in a few minutes. But why don't we, move on to, the panel could only be so big, but also a very interesting innovation in Europe is that the UK is now allowing coordinated sharing with the fixed satellite service in the 3.8 to 4.2 gigahertz range, issuing shared access licenses on a very localized basis. Actually, two different flavors of licenses. I won't go into the details, but just generally, is that a promising way to unlock more unused mid-band spectrum on a localized basis for fixed wireless access, particularly for point to multi-point use in rural areas, etc.? And for now, I'll ask Alex, and as a follow-up, how it's different from his approach, but just more generally, is that
okay.
Go on, Alex.
Our approach is purely really on a 5G campus networks for 3.7, 3.8, and 5G networks below that. So that's not fixed wireless access based on a fixed service and point to multi-point connectivity. It is a very interesting approach what the Ofcom is doing in the UK regarding 3.8. However, if you look to it, it must provide the opportunity to move into that direction. And as far as I'm aware, there are only a very low number of Earth stations available or in use in the United Kingdom of this particular part of the fixed satellite service. Therefore, they have the possibility to make use of the spectrum on a localized basis with a clear, I would say, noise level to ensure that there is no harmful interference to the FSS. And if you limit it further to point to multi-point applications like the fixed wireless access technology, then you have a better control of the whole system as well. So therefore, it's not a complete similar thing. It's an interesting approach, but you must have the environment ready that you can move into that direction. And of course, we will look into some approaches like that as well in order to make further spectrum available, like I think the US is doing as well. And maybe I hand over to Andy what he's thinking on that one, or Charles. Thank you.
Yeah, it's a good point that the fixed satellite service is a special case. And in fact, as a follow-up, let me ask Andy. Andy, you, meaning Google, with Microsoft and WISPA, commissioned the Virginia Tech to do a study that showed the potential for, sharing that, at least in the United States, sharing that fixed satellite service spectrum for point to multi-point. I don't know. Can you mention what you found and how that would work?
Yeah, basically what we found is that the traditional protection distance around a fixed satellite service earth station was malarkey. Typically they're given 150 kilometer radius around their fixed satellite service to keep you out from, because they claim that the co-channel interference is too much. And if you look at the total area, that's bigger than 10 of the smallest United States. So these are enormous protection areas. What we did was, and these protection areas come out of exceedingly conservative assumptions about propagation and the sensitivity of the satellite systems, and who knows what else. Very, very self-serving protection criteria. And so we commissioned a university, Virginia Tech, to study this in more detail, and they found out if you used reasonable propagation models and more realistic interference criteria for the satellite dishes, these protection areas shrank typically to about 10 kilometers, not 150 kilometers. So, an enormous difference in protection area. And what we showed was that we could deploy point to multi-point systems in the same band, and as long as we avoided pointing directly at a dish, or as long as we weren't, free space loss to a dish, we could coexist in the band, and we could use the hundreds of megahertz of available spectrum in C-band to provide point to multi-point service. And in fact, we're following up. We have an experimental license with Virginia Tech, and we're actually following up. We're looking at deploying point to multi-point systems near their campus in shared bands with satellite systems, and demonstrating that in fact this can be done. So stay tuned. You may see point to multi-point soon in the upper couple hundred megahertz of C-band.
Right. Yeah, Jennifer.
Just following up on that concept of sharing with fixed satellite earth stations. I know that Andy, in his description of CBRS, was mostly focused on the fact that we haven't had any interference with the incumbent DoD systems, but don't forget we've also got fixed satellite service earth stations in CBRS, and we've not gotten any complaints from them either. And as Andy mentioned, initially the coordination zones are 150 kilometers, but the FCC's rules allow us to get much closer to those earth stations by looking at the aggregate interference from all of the new CBRS users to those fixed satellite systems. And I think you'll find that we, again, are getting a lot closer, able to get deployments a lot closer to those earth stations, and yet adequately protect them while allowing far more efficient use of the spectrum, in their surrounding geographies. And I think that's probably a really good lesson that we could apply to the 3.8 to 4.2 band globally, in Europe, where there are a lot of fixed satellite systems continuing to operate there, and it may be difficult to relocate them. That's something to consider, is that we've already demonstrated successful coexistence between new mobile systems and those fixed satellite earth stations using this sharing technology that we've implemented already.
Okay, Guillaume?
Yeah, and just the last point on that is that when you're talking local networks, many of the users are actually using indoor systems. Like when you're talking about automating a factory, but there are many other examples which are indoor, and that's a lot easier for the sharing. So if your spectrum sharing system can take into account this kind of subtlety, it suddenly makes 30 dBs of difference, and that's the world really for this kind of range. That really enables to have a better sharing, a more efficient sharing.
Yeah, and I assume that's a big part of the hope for from Ofcom's perspective in allowing this. Yes, Alex.
Yeah, just one thing. The more we share in 3.4 to 4.2, the more we have difficulties later on also in 6 gigahertz. So one of the points why 6 gigahertz is now so a successful story is there was a limitation in Europe of the FSS usage throughout the last decades, and therefore the band was made available for mobile broadband. But then the uplink spectrum, which is in 6 gigahertz, is also available to a certain degree, and therefore we could look into more sharing capabilities. If we now have maybe also deployment and better maybe satellite usage as some kind of backhaul for the 5G networks, if we have smaller ones as well, then we have also additional challenges at 6 gigahertz. So everything is interconnected in there in this spectrum area, and we need to have a good overview of all of the things in order to move forward. But that's only the hint from my side. Thank you.
Okay, so Alex, not to while I have you, and while we're not before we get too far from your application-based approach to 3.7 to 3.8, is we have a question in the chat from Monica Paulini, who asks, how does Germany charge for localized licenses? Also, will the pricing be different depending on the user? For example, for rural WISPs, a city or school or an enterprise. And finally, can service providers that are not mobile operators get a license, for example, to operate a neutral host network inside a large venue?
I start with the last question. If they would like to offering services like an ISP, then they will not get a license in 3.7, 3.8. That's only for local internal communications. It's not intended for public service. The question regarding the charges, it's not a linear. We take into account, of course, the area which is served, the amount of the spectrum which is used and should be used. So if it's cheaper if you use only 10 megahertz or if only 40 and not the 100 which is available, and of course there is also a question of the timing, how the duration of the license is moving forward. So therefore all of these aspects are taken into account into a formula, and then this forms some kind of incentive administrative pricing, which moves forward with quite reasonable pricing compared to other spectrum already. It's a little bit similar to the FS pricing we use as well. It's not completely the same, but I made the factors clear. And the last question was, is it different for different users? No, it's not. Of course, if it's a campus network for public schools or universities, there are certain regulations in place in order to keep these fees down. But these are only exceptions, but they are generally applicable and not only for 3.7, 3.8.
Okay, great. So moving on, so as we're thinking about these new mechanisms to allow smaller players to gain access, a wide variety, and you would think with Internet of Things that there could be a real mushrooming of demand for direct access to spectrum on a localized basis. Alex, as you just have explained, both Germany and the UK, the sharing is premised on applications to the regulator and a manual coordination process. So I'm wondering, maybe particularly you and Guillaume can address, why hasn't the EU moved yet toward automating shared access to underutilized bands by leveraging, for example, geolocation databases, as the US does with CBRS? Do you think Europe will move in that direction, or are there some reasons that's just simply not a good fit in Europe?
Do you want to start, Alex?
Yeah, I had some network problems right now, but I understood the question. No issue. But one thing you need to know about the EU on this particular point, the implementation, so the authorization process is definitely within the remit of the national countries in Europe. And the EU, if we move forward toward an automatic approach, we should be ensured that all of the aspects are already set clear by all of the different nations. And therefore, it's really a tricky issue in order to grab into that one from the European side. Of course, we can set up the technical framework for it, which can then be used as some kind of toolbox and move forward. And of course, we can work into that direction. However, we would like to see also then the good examples from the US and maybe take that over and adapt it to Europe as well to a certain degree.
Okay.
Up to now, as I said, we need to have also some kind of cost-benefit analysis if it's really applicable to everybody in Europe, and then move forward in that direction.
And it probably depends also on what the incumbents are. So if you look at what Ofcom has said, they said that they intend to move over time to a more dynamic spectrum access model, something a bit more automated. So it's already in their plan and they want to do it. There have been discussion in other bands in Europe where the incumbent was a little bit sensitive. So it could be something which is military, for example, where even exploring that through a database may give some ideas to people that are external about where the system are used, and that's becoming super sensitive. So it's more about what the type of incumbent you have that puts a restriction on what kind of dynamic system access you can put in place. But otherwise, I think Europe is interested. They will progress with that. Yesterday, Mr. Bregan mentioned that they already have a proof of concept in France. UK is saying that they're going to move towards that. It's just a matter of time.
Right, an evolution, and that's definitely a good point Alex made on, which I'm sure Charles could reinforce. But that the U.S., the Federal Communications Commission preempts all the 50 states, so there's no question of having to the different jurisdictional choices. Jennifer, do you have a point in this?
Yeah, one of the comments there I think that was made is the sensitivity of the incumbent information, right? And whether or not that information should be made public in order to be accessed to enable sharing to occur, or if it could be maintained in a private database and credentials, a secure system enabled for the spectrum access system or AFC coordinator to access on a confidential basis. And, I'd look to Charles to tell us if we're doing a good job. But, I think we spend a lot of time in the United States working with the military to make sure that their very sensitive information is kept private, and that we're not risking, national security, and that, we're obviously demonstrating that, such security issues can be worked through. And at the same time, as regulators, in Europe or elsewhere are looking at how to implement database-enabled sharing, again, these databases, while they need to be accurate, don't necessarily need to be public. We can create and form ways of making sure that there are secure connections between any database administrator and the regulators' databases that they're using to track incumbents. And I imagine that's going to be the case as we are moving forward with, implementing our streamlined secondary market processes in the CBRS band, and would like to replicate those into other bands. We're going to have to work with the big MNOs, and their information about where they've deployed their systems is going to be sensitive, competitively sensitive. And, we'll work with them to ensure that that information is kept private, but yet, facilitate them being able to lease out their spectrum to others, as efficiently as possible. So I think it can be a win-win here, and we can find ways of making sure that information that needs to remain private can do so, and yet make more efficient use of the spectrum.
Great. Let me move on to ask Charles. Charles, you focused in on the 200 megahertz of military radar spectrum between 3450 and 3650 that either has been or will be auctioned subject to protecting a degree of ongoing military use. And Andy mentioned that he's actually, very positive about the potential for incumbent informing capability that you described to be more effective than the spectrum sensing capability that's currently used in CBRS. So I'm wondering, could IIC, well, first, if you agree with Andy, and second, could IIC also make it more possible for the military to share more of the 3 gigahertz band below 3450 megahertz?
The NTIA earlier this year, in January of this year, published a report dealing with a pretty thorough technical analysis of the incumbent services in 3450 to 3550, recognizing there are 3 types there. Beyond the Navy ones that you identified, Michael, we also have land-based radar systems and also airborne systems. So each require its own type of analysis to determine how that can be either shared with, and we actually, and that kind of goes along to the other parts, is what are the mechanisms we have? Well, we have 3. I mean, we can make the agencies can make operational changes, right? Choose not to operate in that geographic area or make other modifications. They could relocate their system to other frequency bands, or if there's a sharing mechanism, share. So, recognizing there's airborne, naval, and land-based, and you also have 3 different types of accommodations that can be done, you get to have kind of an interesting matrix. But certainly with the IIC, for those services where maybe not quite real time, but almost close to real time, when those active devices, when those active radars will be turned on, those can be scheduled. That would be an appropriate mechanism. So the goal here for the NTIA is, we envision that this could be potentially shared with other spectrum bands and other bands as well that may involve many other federal agencies possibly. So I think the guiding point on this is federal services that have the capability to be scheduled in advance, and advance could be just a few moments before would have great flexibility to use that IIC.
Great, thanks. So let me because we're getting short on time, I'd like to just get one more concept out there, which is because we haven't touched on the 6 gigahertz band, and not to ask that so much explicitly, but the focus in 6 gigahertz for unlicensed sharing has been low power indoor only, and it seems that perhaps an unappreciated development here is that regulators are recognizing that very valuable spectrum can be used, even heavily occupied spectrum can be used indoors by whoever controls the building, if this does not cause harmful interference to primary users outside the building. The US first considered this for CBRS, although it wasn't adopted. It was called contained access facilities. So there's some power level at which you can operate perhaps without interfering with, say, airborne radar or any number of services that are predominantly outside, even if they are the primary licensee. So my question is whether this approach has the potential to open additional spectrum bands for indoor use and enterprise networks going forward.
I'll take a step, but I thought the contained access facility was a great idea the FCC had, and they dropped it at the last minute and didn't adopt it in CBRS. I think there's merit to assuming that if you put something inside, there's better separation to systems outside. But you have to be careful not to rely on that at all time, right? If you put a system right next to a window that's not conducting or whatever, so that there's no attenuation, you can have interference to outside systems. So I don't exactly know how you would control that. If you say you use something indoors, but it'd be hard to enforce telling a user not to put it near a window or something like that. So we have to be a little careful. I think the general idea is good, but there can be circumstances where, depending on where you place the device indoors, it could still cause interference.
Yeah, so lots of details to work out. Guillaume?
And And there may be some, beyond midband and having the container, as Andy spoke about, there may be some millimeter wave frequencies that this may be adaptable to. For example, the commission has an open item now where we're looking at 37.0 to 37.6 gigahertz and sharing with federal users. So there's a potential there to explore that. And I think the physics may be a little bit more amenable to that as well due to the higher frequencies.
Okay. Yeah, that's a good point. One last quick question from in the chat box from the audience. Oh, I'm sorry, what?
Can I just to add one thing, that there's maybe one element that could be very important in context of indoor usage, is that when you use TDD outdoor, typically you rely on synchronization when you have other networks in the area. If moving indoor allows you to use a different frame, for example, if you want ultra low latency and these kind of things, that should be able to be taken into account so that factories can be automatized. So that's an element. It can get access to other bands by going indoor, but it can be also a relaxation from some of the other constraints that you may have when you are outdoor. So it's one of the elements that you should take into account into your package.
Yeah, and that may relate to this last audience question for Alex in particular, or anyone. If you award multiple local licenses in the 3.7 gigahertz band, and typically TDD systems are deployed, how do you avoid harmful interference?
Yeah, thank you. One of the key measures there is definitely minimize technical interference settings for the networks, and we ensure this with a clear threshold value, which is applicable in the end and will be controlled by the network agency if there is no agreement between the network operators. So if you have different networks, then they need to consult with each other in order to synchronize their networks, or ensure that they reach only a level which will not create any harmful interference to their networks. That's on both sides and on all sides. So it's quite a challenge if you have a rather dense area with a lot of campus networks and maybe then side by side with the mobile network operator. So it's for some of the people, they really need to have further advice, but they need to work out definitely their environmental interference scenario and minimize with power settings, with antenna sectors, whatever measure is necessary in order to minimize their interference level at the outside of their building and the outside of their coverage area.
Right. Well, thank you, Alex. All right. Well, I'm told we're at the end of our time and must wrap up to stay on schedule. So I want to give a big virtual round of applause to this incredible panel. We covered quite a lot of ground, and I really thank you all for joining us today.